Okay, so let's look at our first section, which is section 1.1. Okay, 1.1 is basically, as I said, a little bit of review on algebra. We'll talk a little about square roots, maybe a little geometry as well. All right, first thing we're going to take a look at is what's called the distance formula. Okay, how many people remember this? Either from geometry or somewhere. You got 2 points and you find the distance between them. People have done that before? Yeah. Right, so generally when we have a distance formula problem, they'll give you 2 coordinates. They might call the points A and B, or point 1, point 2, something like that. They'll give you the location of each point. And they'll have you find how far apart the 2 points are. Right, so there's an example. We got point A, point B, and we just want to know how long that segment is. Okay, that's basically what the distance formula is used for. Okay, anybody remember what the distance formula is? Remember that? All right, well, let's take a look at the picture, see if we can figure it out. What I want to do is I want to make a certain shape, and this is going to be one of the sides of the shape. Okay, I talked earlier about what shape we're going to use a lot in trig. So what shape do you think I could make out of this segment? Yeah, let's see, Zach?
Triangle.
Yeah, let's make a triangle out of it, all right? So what I'm going to do is draw, let's see, okay, line a segment on the bottom. You know what, I really don't want arrows on each end. I'll just do it by hand. Okay, so there's my bottom. Okay, and my height. Okay, and Kaylin, what does that symbol mean right there? Remember what that means? Yeah, it means it's a right angle. Okay, it means it's a 90 degree angle. Right. Now, is there any formula, any theorem that you already know where if you know the length of 2 of the sides, you can find the third one in a triangle? There's a formula for that. Yeah, Ashley?
Pythagorean theorem?
Yeah, the Pythagorean theorem. Okay. So all we have to do is measure the bottom side, measure the height, and then we can get the angle, get the line that's on an angle. Okay, the hypotenuse. All right, so this point starts at x1 and goes over all the way to x2. How would we find the length of that bottom piece? If it starts at x1, finishes at x2, what would you do with those? Pretend they were numbers, like 10 and 3. How would you find out the distance between them? Zach?
Subtract x1 from x2.
Yeah, you just subtract this one minus this one. Okay, you can do it in either order. Let me see how I did it. Yeah, I did it like that. So the length of this bottom side is x2 minus x1. That's the bottom. All right, so if x2 was 10 and x1 was 3, the difference between 10 and 3 would be 7 units long. Just subtract those 2. Okay, and then we got to do the same thing for the height. It starts at y1. It ends at y2. So how about Analia? Well, how would you find the height there?
You would subtract y2 from y1.
Yeah, same thing. Let's say y2 is up at, I don't know, 12. y1 is at 3. You do 12 minus 3, and that would give you the length of 9. Okay, whatever it is. So there's your height. There's your base. Okay, now somebody earlier said that we can use the Pythagorean Theorem. Somebody remind me, what is the Pythagorean Theorem? Yeah, go ahead, Charlie.
A squared plus B squared. B squared equals C squared.
Good, perfect. A squared plus B squared equals C squared. What's A, what's B, and what's C?
C is normally the hypotenuse.
There you go. C is the hypotenuse. And what about A and B? Anybody else remember what those are?
Legs.
Yeah, those are your legs. Well, we just found the length of our two legs. One of them's x2 minus x1. The other one's y2 minus y1. We're just going to take this, plug that in there, take that, plug that in there, and then we'll have our distance formula. So your distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. And now the only thing different here is I have this big square root over everything. Why did I do that? Do you see where that square root comes from? Yeah.
The answer you get for C is squared, and you want a regular answer.
Right, we're trying to find this. We don't want to know what the length squared is. We want to know what the length is. So if you take the square root of each side, we can cancel the exponent on C and get C by itself. So this formula is exactly what we have on the other page, just filling in A and B. And that's it. That's your distance formula. Let's try that example. Okay, find the distance between the points 4, 5, and 3, 2. Okay, generally what I try to do so I kind of know what's going to go where, I just label everything in the problem. What's x1, what's x2, y1, and y2. So John, what is 4 in this case?
X1.
Sure, could be x1. And that would make 5 what?
Y1.
Y1. Okay, and Jake, what about 3?
X2.
Yeah, x2. And the 2?
Y2.
Y2. Now we just have to fill those 4 numbers into the formula. Okay, so my distance is going to be the square root of Jess, what are the first 2 numbers I'm going to subtract? What minus what?
2 minus 12.
So what's x2?
3 minus 1.
Yeah, 3. And what did you say x1 was?
4.
Perfect. Okay. 3 minus 4. Okay. And then the next 2 numbers I'll subtract. Ben?
It'll be 2 minus 5.
Yep, 2 minus 5. Would it have made a difference if he did 5 minus 2?
Yes.
Well, normally if you do 2 minus 5 or 5 minus 2, you get a difference, but then we're going to square it. So would it make a difference if we square it? No. All right. If he did 5 minus 2, he would have gotten positive 3. Squared is 9. Here we've got negative 3. Still, when you square it, is positive 9. Okay, so we get the square root of 3 minus 4 is negative 1. And Chris, what's negative 1 squared? 1. Okay, we just said 2 minus 5 is negative 3. Squared is 9. And there's our distance, square root of 10. If on the test or on the book, they ask you to round that off, just use your calculator. Okay, square root of 10 is about 3.16. Okay, if they wanted to do this one. Okay, any question on finding the distance there? All right, let's look at this one. Okay, take a second, see if you can do that one on your own. Okay, find the distance between the point 2,6 and 410. Okay, if you get stuck, let me know and I'll come around and I'll help you out. Okay, so as we go through it, start with your big square root. Sometimes I just fill all this in just like this, just so I have all the spots to plug stuff in. Okay, we fill it in, you got 4 minus 2. That's how most people did it. And then 10 minus 6. Okay, I saw a couple of arithmetic mistakes just with the subtraction. I think they were thinking ahead to squaring it. So they wrote 4 minus 2 was 4. But I think you're thinking of the next step. Okay, so 4 minus 2 is 2 squared. 10 minus 6 is 4 squared. So we get 4 plus 16, which is the square root of 20. Okay. What can I do with that?
Factor
Yeah, what does this end up simplifying to?
2 square roots of 5.
2 square roots of 5. Okay, and I'm going to show you how you can do this. Okay, there's many ways to do it. One way I do it is I factor it, okay, as 4 times 5. And one of the numbers you factor it as has to be something you can take the square root of. So 2 and 10 wouldn't work well. 4 and 5 works perfect. Square root of 4 times square root of 5. Square root of 4 is 2. Square root of 5 you can't reduce. Okay, so anytime you see a square root, we do have to reduce. Okay, if you some people make like a tree, they do like the factor tree to simplify it. That's fine too. Okay, however you do it. Okay, but what I try to do is factor the radicand, that's the number under the square root, so that it's a product of 2 numbers, one of which is a perfect square. Okay, so your perfect squares are numbers like 4, 9, 16, 25, things like that. And then you break it into 2 roots, just like I did. Square root of 4, square root of 5, and then simplify the one you can. Square root of 4 is 2. Okay, so we already simplified the square root of 20. So let's say you went through the distance formula. You ended up with square root 48. Anybody tell me how I can break that up? And there might be more than one way. Yeah, exactly.
12 and 4.
Okay, that works perfect. Okay, you could do 12 and 4. And the square root of 4, Andy gives me 2. Now, what about 12? Yeah, we can simplify 12 again as 3 and 4. So that 2 stays right where it is. Just factor 12 as 4 times 3. And I'm going to get another square root of 4, which is 2 again. Now, we had to go through and do that twice. We had to break it up and break it up again. If you did it twice, there's probably a way you could have done it a little bit better just in one step. Anybody see another way you can break up 48? Get the same answer in one step.
6 and 8.
Well, can you take the square root of 6 nicely in your head? No, how about 8? No, you can take the cube root of 8 nicely, but not. But 6 and 8 does multiply to 48, but that won't help us here. What else could we do? Yeah, 16 and 3. 16 times 3 is 48. Watch what happens. You take the square root of 16. Okay, so there's always a way to simplify square roots in one step. It's not wrong if you do it in multiple steps. It just takes a little longer. Okay, but you always want to make sure you reduce it as much as you can. Any question on reducing square roots? It's okay? How many people have done that before? Pretty much everybody. It's pretty easy. And last thing we'll do today is the midpoint formula. Okay, so midpoint formula, basically we use that if you want to find kind of what's the middle point, what's the halfway point between 2 points. Okay, what do we call that numerically? Like if I had 2 tests and I wanted to know what the middle of those 2 tests would be. I'm trying not to use the word. And this is basically what we're going to do right here. Ashley?
The average?
Yeah, it's the average. Okay, that's all we really do in the midpoint formula. You add up, if you add 2 things together and divide by 2, that's the average. So basically you take your x's and average them, take your y's and average them, and that's the midpoint. It's just the average of the x's, comma, average of the y's. So this time, our final answer isn't going to be a single number, okay, like it was with the distance formula. It's this thing with parentheses and a comma in the middle. Okay, what do you call this thing? Get the parentheses, 2 numbers, comma, yeah. Yeah, it's a coordinate, an ordered pair. Yep. So it's a location. Okay, it's a location on a coordinate plane. Right, so see if you can find the midpoint between those 2 points. Okay, if you want to label them, if that helps first, go ahead and label what's what. Remember, each coordinate has an x and a y. Sometimes they'll go x, x, y, y. They get messed up. But you want to go x, y with the first one, x, y with the second. Okay, so take a second, see if you can get that. Don't worry about any decimals. You can leave things as a fraction if you want. All right, so John, what's my first step here to find the midpoint?
Add 3 and 7.
Perfect. I'm going to take 3 plus 7. And what do we do with those 2 numbers once we add them up?
Divide by 2.
Yep, I'm going to divide by 2. So we got 3 plus 7 over 2. And Callie, what about in the second part? 4 plus 13 over 2. Good. Okay, and just simplify it as much as you can. So Hannah, what's 3 plus 7? 10. And then divide by 2? 5. Perfect. So we get a nice integer there, no fractions. And then Jacqueline, 4 plus 13?
17.
Does 2 go into that? No. So we can just leave it as 17 over 2. Or if you want it as a decimal, 8.5. Okay, so any questions on that? All right. So with the time we've got left, we've got about 15 minutes. Okay, I'm going to let you start the homework. Okay, it's on page 7. It's 15 to 21, 39 to 43 odd. And I'd like you to try to simplify these 4 square roots. Okay, a lot of people forget to copy these down. Okay, so copy down these 4 square roots and try to simplify. Okay, and we'll take a look at that tomorrow.